Tech in 5.
Python in practice, master real-world projects in 5 minutes. Train, evaluate, and save/load your neural network model. Let's start. Welcome back. In our last episode, we built a simple neural network with PyTorch and started the training process. Today, we're diving deeper. We'll continue training our model, then evaluate its performance and learn how to save and load the model for future use. Let's jump back into our training loop, where the real action happens. Our neural network is now learning to recognize patterns from our dataset, making subtle adjustments with each batch of data. In the training loop, we loop over our dataset multiple times, in this case for 10 epochs. Each epoch represents a full pass through the dataset, crucial for the network to learn effectively. During each iteration, we start by fetching our batch of data, images and their corresponding labels. With this data in hand, our model first resets any previously calculated gradients, ensuring that we start fresh for each batch. Next, we perform a forward pass. This is where our model makes its predictions, feeding the input data through the network layers. Immediately after, we calculate the loss. This loss tells us how far off our predictions are from the actual values. It's a crucial feedback that guides the network on how to improve. With the loss calculated, we move into the backward pass. This is where backpropagation comes into play. The model adjusts its weights based on the gradient of the loss, learning from the mistakes it made. Once the gradients are computed, we update the model's weights using our optimizer. This step is critical as it directly influences how the model's performance improves over time. Throughout the training, we keep track of the loss, printing it periodically to monitor our progress. This feedback loop is what allows us to refine the model's accuracy, reducing the loss with each epoch. You'll notice the loss values decrease as the training progresses. Starting from about 0.93 in the first batch, the loss steadily drops down. This trend is a good sign. It means our model is effectively learning from the data, refining its ability to predict more accurately with each batch. By the end of training, the loss drops down to 0.05 in the final epoch. The consistent decrease in loss values confirms that our neural network has significantly improved in recognizing the patterns within our dataset. This gradual improvement is exactly what we aim for in a successful training session. With our model trained, the next crucial step is to evaluate its performance on data it hasn't seen before. We use a test set, a collection of data separate from the training data, to assess how well our model generalizes to new, unseen situations. This is a key step to ensure that our model is not just memorizing the training data, but truly learning to recognize patterns. The results are in. Our model achieves a test loss of 0.09 and an impressive accuracy of 97.45%. This tells us that our neural network is highly effective, correctly predicting the correct labels for the test images most of the time. Now that our model is trained and evaluated, it's crucial to save our work. This allows us to use the model later without needing to retrain from scratch, a key step in deploying machine learning models. Saving a PyTorch model is straightforward. We use the torch's save function, which allows us to store the trained model's state dictionary. This dictionary contains all the parameters of the model. We've just saved the model to a file. This file can now be transferred and loaded on any compatible system. Let's demonstrate how to load this model back into PyTorch. Whether it's on the same machine or a different one, loading the model is as simple as creating an instance of the model class and loading the parameters back into it. With our model now saved and reloaded, we can ensure the longevity of our training efforts and facilitate easy deployment across various platforms. And that brings us to the end of today's episode. We've accomplished a lot in just a few minutes, continuing our training process, evaluating our model's performance, and learning how to save and reload our neural network. You now have the tools to not only train a neural network, but also to ensure its effectiveness through evaluation and make it reusable across different projects or platforms. These skills are crucial for any aspiring machine learning practitioner. Thank you for joining me today. See you in the next video.
Stay tuned for more videos on Tech in 5.